I'm Rimantas. I'm coming from the Cognizant company. It's probably you will know better it from the Formula One team. We're doing this year pretty well, but unfortunately I'm not working on the Formula One team. So, so it's going to be around a little bit different, around the enterprise clients. And today I'm going to talk about the building of analytical platforms, and it could be called the data platform. Different companies has different name, but basically it's how do we expose the data from the company that the company acquired, and how do we make sure that that data is available in the organization in a seamless kind of manner. And I've divided the talk into 3 parts. One of them is why do we still struggle? Why does companies still struggle of using the data? That is, we are collecting more and more data. We hear like success stories like Google, Facebook, or other companies that harvest the data and use that data very efficiently. But if we are diving into the actual companies, there are problems. It's not always possible to get the proper data. And it's not always possible even to find the data in the organization. And I will introduce the concept, the data as a product. How do we change the culture? How do we start treating our data to be successful? And then we will kind of dive a little bit in the analytical platform build, what features it needs to have to be successful and useful. Mostly it's kind of how do we build it so it lasts, so it's usable for a long time. So let's look at the numbers a little bit from the beginning. So if you Google the number, how much data do we collect every day? It's 2.5 quintillion, and I actually had to Google how many zeros is there. So it's 18 zeros of the data every day. And I checked it with the ChatGPT as well. It says exactly the same because it harvested that data from internet. But the important part is that not all of the data is useful. And I think the worst part is that not all of the data is used at all. So let's look at the numbers from the enterprises that are collecting the data and at least trying to use the data in some sensible manner, and want to become a data-driven organization. If we look at that, it's like this is the 2021. I've checked the 2022. It's around 25%. So basically, it's only 1 from 4 organizations that are able to do the properly use the data. And what is the problem? What is the problem? Why are we stuck in such a state? And why we are struggling? Why can't we just simply use the data that we have in a proper manner? And the interesting part is that technically we have everything in place. So we have a proper tools to store the data. We have a proper tools probably to query, to do the analytics. But the problem is that to become a data-driven organization, it's not the technical path. You need to change the culture, how you deal with the data. And if you change that culture, then it kind of drives, then you take the technical bits and then you can actually become a data-driven company. The interesting part that we can very quickly to relate to what we had with the software development. And if we're looking at the history, we had exactly the same issues, right? When the applications were small, monolith, maybe covering just a small domain, and the engineering team could actually have everything in mind in the context. They could kind of build it, that grew, kind of works pretty well, even in the monolith way. As soon as we got getting more and more processes digitized, more application appeared, right? More domains, those domains started talking to each other. It became impossible to overlook all of those connections, and we had to change. We had to change the architecture. We have to change how we work with that, because the architecture, for example, the microservices. It brought multiple things in place, and then we realized that we need some rules. We need some rules to be able to kind of to juggle those microservices. So the DevOps kind of came in place. We have the virtualized stuff, containerized, interesting. So that means that we changed not only the architecture and tooling, but we also changed how we think about those. The ownership of those items became, there is a concept of you build it, you run it. So basically you put all of the thinking into that. Now if we switch to the data world, that's a little bit different. So again, we can say like we had a storage, the application was writing to a disk, it was some storage, then the databases appear, one appliance. But what happened when we had more domains? More data coming from different transactional systems. So basically, we invented kind of ETL part, right? So we have multiple domains, different storages, different applications. We simply took all of that and moved into warehouse. So basically, everything that was in separate domains, we moved it into one place, and then started building the products on top of it, data products. So either it's reporting, either it's a specific usage for analytics, but basically not much change. So basically we increased the bucket, added everything in one place, so it's now distributed, it's in the cloud, but conceptually it's the same. So there was also another concept of let's do the data lake. So it was data warehouse, then we moved to the data lakes. But basically, if we had a trash can and we moved all of the stuff into cloud, so it's just a bigger trash can, right? So it didn't improve anything. We just have a bigger bucket. So it doesn't solve the problem again. So let's look. The software improved, right? But in most of the cases, if we look under the hood for the applications, enterprises, we have multiple clients. If we look under the hood, even though the front end looks very nice, the application, it could be front end, could be the back end part. But if we look at the data world, it's a mess there. So it's difficult to find things. It's not clear what's in there. Lots of logic is done in the back end just to clean up everything here. So the question becomes, how does this happen, right? How did it come that we're in this messy world? That we moved with the software, we're still kind of struggling with the data part. So so I will actually, walking through the data warehouse, I will show where typically enterprises trip up, where the problem lies. If looking that's why for smaller companies or like specific domain companies, it's way easier to move towards the data products, and it's very difficult for old legacy kind of with a lot of systems companies to shift the mentality. And the problem is actually on the ownership or how they separate the data processing silos. And you can quickly see that we have operational databases, or it could be transactional databases, then we have some logic that moves that data into the warehouse, and then we have the analytics part. If you took a typical probably enterprise, financial institution or something at that point, you would see that all of the applications, they are not done by separate teams. So there is a silo application development. Everyone is doing their stuff. It doesn't mean that it's bad, the applications itself, but they know the domain, they know the data, they know what's written into those pieces. Then we have an ETL team. That's totally separated from the application teams. It's a separate department. Their responsibility is pretty simple. You have to move the data from applications, move them into warehouse. So they're actually doing a good job as well. They're moving the data from sources. They're moving that into data warehouse part. And then we have the analytics team. The analytics teams, they live in the data warehouse, they look at the tables, they search for the data. As soon as they have the data, they try to do reporting. And the worst part that sometimes those teams are also siloed. So there are multiple analysts are working on the same stuff. So they're building like orders 1, orders 2, orders 3 views where they have the different means to cleanse the data and different means kind of to process the data. And this is the problem. If we look at this, nobody is looking like throughout all of the cycle. So nobody is looking from the product perspective, where it needs to come, how it needs to go. This is why we added in the microservices. This is why we have the API gateways. We have the reporting and everything. Just to make sure that we have the whole visibility. So to have a lot of data, it's I would probably compare from the development point of view, is sometimes when you have a requirement, just monitor everything. Just take everything from your application, put somewhere, and then you have a lot of data, but it's not much meaningful if you don't kind of understand what's in there. Are we missing something? Nothing. So basically, it's nice dashboard, right? But it's inactionable. So you don't know what needs to be done with that data, even though you have it. You don't know whether you need it. So that's very similar with data. And this is where that culture change needs to happen. We need to move a very similar way how we done with the software. We need to move with the data as well as a product. So we need to start treating the data not just as a source or a source for my report, but we need to treat all of it as a product. That means from business perspective, from business requirement, back to the source and everything in the middle. And that everything in the middle means I have to understand what data I have. Is it good? When it was loaded? All of those bits, how it matches. And I have to be able to repeat it all the time. So it's productionizing. So it's not a console app on your machine, which works just on your machine. You need to have it as a product. And there is a small distinction. Like if you're building a report, be it an application, maybe you're showing to the client, maybe it's a BI report, maybe it's Tableau report, maybe it's just a API that you're sending the data out. Basically, you're doing the data product. But it's not data as a product. It's just anything that you use the data for your product. And then there is a discussion data as a product. And this is where the distinction is similar to the application that you build out yourself to run on your machine and the application that you actually build out for everyone. And this is the important distinction, because if you're building it just for yourself, you don't care about the secret management, you don't care whether it crashes or not. A lot of bits are missing. And this is very similar with the data. If you don't care what happens with the data from the beginning, that means you cannot have a proper, long-living product, data product. So let's translate that a little bit to the organization. We'll talk a little bit about the data mesh concept. And the data mesh actually says that any team that produces that data or owns the data should be producing also the analytics or anything that's related from the business perspective. This is like a simplification of the domain. So we have 3 domains. And it could be that we are running 3 microservices. It could be separate teams that are actually building those. And at some point, there is a requirement to create just like demographics of the listeners. It's as a product. It could be API. It could be Power BI report or whatever. But basically, responsibility falls on the podcast because they have the data. They are able to do that. And data mesh says that if you have something, if you have domain, you also produce the data products as well. So you're producing the application itself, but also the data reports or anything that goes out, and you own it. If you need that data, you pull it in and you create your own product, right? And it's traceable. So the user's domain responsible for them because they understand the data, they know the quality, they can cleanse it, they can do whatever they want. But basically they create an interface of the data and they treat it as a product. And you create the interface and treat it as a product as well. So those are two different data products that are created and maintained throughout as an application. So there are multiple, let's say we can have multiple architectures of data mesh. And the one that I talked about is this where everyone is responsible for everything, they maintain everything. But in reality, that means it's like microservices, right? You can use any technology, anything, as long as it has a clear interface. In the real life, this is a mess, and it escalates really quickly, and you want to have some rules or some shared stuff, common stuff in organization that could be used. So there are, let's say, the intermediate one version. It's a hybrid where you have some of the things are distributed through specific distribution domain, or some functionality is available for multiple domains, and there could be some domains which are totally isolated, they live on their own. And then we have a governed mesh where there is a specific product or something, the functionality that is available for all of the teams to use and to distribute their data. That means they're productionizing some of the functionality through this distribution domain. And when talking about the data platform, we will talk about the distribution domain, about the product that could encompass all of the features that would allow domain teams to push their data into general place or like a single place in the organization. So let's talk a little bit about the data platform, about the features which needs to be in there for it to be successful. And not just successful, but actually long-living. There is always a question when talking about the platform, whether you should build it or should you buy it. Because like platform is always kind of automatically seems it's expensive, it's a long way, so maybe we can buy it. But remember, I talked about this is the cultural change. It's not just around the product. So you can get in a market, you can get the products that try to get everything in one place, like Informatica, could be Databricks to a certain kind of extent. AWS has all of the services that you can collect into one place. Azure has it. So just be aware that the cultural part you cannot buy. It's like microservices. There is no product that says like if you bought it you have the microservices. So basically you would still have to change the culture at a certain point. So let's look what we would try to achieve with the data platform, and then we can explore the items that it should have, and I will probably give you some pointers what works well or where you can start. So there are a couple of things that you need to have in the data platform, and there is one of the things is the data should be easily discoverable. So it's either some kind of documentation, automatic documentation, or where the people can simply find the data. The data that's in the platform, it should be understood. So it should be trustworthy and truthful. So you should understand what's in there. It should have some metrics around it. It should be possibly have some tests around it. And by looking at the description, you should be able to say, what's in there? Do I trust that data? Is it good enough for me? Because you will be defining the product based on that. The other part is if I discovered some data, it should be easily addressable. So to get that data, it should be pretty easy or uniform way of getting that data. So all of the data should be reached in a same manner. The other part is that it should be self-describing and interoperable, so it should be possible to easily understand the data which you discover. Should have enough data there. And interoperable means that if you have like order ID in one data set and in another, it's the same. So it's not meaning two different things, but basically you can connect on them later on. And of course, the security is the important part of this one. You want that data to be secure. You want only the necessary data to be passed on. If it's personally identifiable information, possibly have the capability to mask it. The other part that's usually overlooked is the data ownership perspective, because we are talking about the domain that will be used by multiple teams, so it should be possible to like self-service. It should be understandable by all of the teams how they should put the data in, how they should take the data out, and how do they create the models. So let's dive into each of those and see what bits are important in here. I have some logos here, but I will talk more around the concepts, and then probably you can use the tooling, but as long as it kind of fits in the concept. So one of the most important bits for self-discovery is some way of describing the data or having some documentation type. And one of the things that the DBT does pretty well, it's a tool. It goes more or less as we have infrastructure as a code. So basically it's like data as a code. So you initially define the data and only then perform everything else that you need. Be it kind of extract, load, transform, making models. That's everything is described. And the neat part is that we need to have it in some shape or form that's human readable. If it's in the database, then you need the tooling around it. You need to have the interfaces. It's difficult to work directly. So it has the YAML file. The YAML is probably very easy to understand. In most of the cases with this platform, it's going to be not the business people, but more or less engineers, be it from the data engineering part or the other team, so they will understand this. It's easy to convert to JSON. It's easier to write in YAML because you don't have those brackets. So it's important to choose the description of your data. It's important to choose that it's easily understandable by multiple engineers or people. So if it's going to be easily understandable, the people will use it. If it's very difficult, if it's steep learning curve, they will not use it. The other part, it should be easily extendable. You will not be able to start with a heavy platform immediately or like build full out functionality from day one. You will be building it incrementally. That means your schema will grow as well. So if the tooling or anything that you pick with the schema, make sure you can actually grow it. If you want to add more stuff, more tests, maybe specific tests for your organization, maybe specific flagging for your organization, that schema should be extendable. I would probably suggest before building your own, just look at the DBT, maybe take it as a base point, extend it with your own stuff. If you're using like AWS Glue, that's going to be very difficult, Glue catalog, because it has predefined structure and that's going to be difficult to extend. The other part is the incremental change support. Obviously, as the platform grows, more and more stuff should be available in here, in the description, in the data metadata. And less magic, better. So any tool that performs something underground, either discovery or anything, it's difficult to understand. The people will not understand where the stuff came from. If you have one-to-one relationship between definition and then the actual object, it's way better. Also, don't forget the version control. Again, if you're using the YAML stored in Git, you get that out of the box. If you're using some tooling which has the data catalog, make sure it also has the version inside. The other part is the clear deployment pipeline. I would always pick any tool that can actually store the definition in the Git or somewhere and populate their own tooling or the database from that definition, rather than have a tool which stores its own database, because then you can get the vendor lock-in. And this is the last part. Most of the tooling will try to get you into vendor lock-in. So basically you get everything from one, but you need to use all of the tooling from them. And then it's very difficult to migrate. Those definitions are your data descriptors. And if you give the control of schema for someone, it's going to be difficult to migrate or move to any other tooling. There are two ways to go around the data catalog or data kind of definition part. One is at least most of the enterprise kind of tooling, like Informatica, the AWS Glue data catalog, they're able to pull from data sources all of the objects and just kind of show you in the data catalog. And also, there is other option like DBT, is where you describe first and only then the data appears. So I would probably opt in to go with the definitions first, because that enforces the cultural change, that you describe the data first and only then you use it. If you use those auto discovery, it pulls everything. You don't have the documentation. Half of those stuff is just going to be the names of the table, and if anyone worked with the Oracle tables, you'll understand that there is impossible to do kind of to understand what's in there. So that changes already the culture. First define the data, only then use it. And when we have that, the other parts follow. So let's look at the trustworthy and truthful. We want the data to be correct, and we want data to be consistent. If we are defining it properly and only then using that definition to load the data, that allows us to create the standard pipelines. So basically the pipeline always runs the same. It picks up the definition, it loads the data, puts it in the warehouse, wherever you have it, intermediate storage, and it just iterates through it. So you don't have to create the pipelines for, let's say, for each of the data source. You can have the standard way of ingesting the data. And as I said, it can grow, right? You can start adding specific tests in there. So basically, if you have a definition, you can say, my platform supports specific stuff, and I can add those. Those adds the consistency. That adds the visibility. What are you doing with the data? What are you testing? And it always runs through the same. So you get the consistency between all of the loads. So if somebody created the load from SQL Server, that means all of the SQL Server loads will be exactly the same. You get the consistency. It's even if it doesn't become that one team created the test, but the other one forgot it because it was not in their requirements. You can use the same, and you can grow the pipeline. The other part is the data ingestion monitoring. So when you have one pipeline of loading, consistent pipeline, you can start monitoring. Did it load? How many data load? And then you can have some metrics around the data, and it immediately can be hooked up to definition. So anyone who's going to be discovering the data, they can say, okay, the last load is specific date, number of rows that were loaded, and maybe even the results of the tests. You can have the biases and other kind of more analytical stuff hooked up to a data set. And as you have like a consistent load, you can also build out the lineage from there. So you will know where did it come from, what operations it passed, and what do we have right now. From the tooling, it's probably for the ETL, you can choose multiple ways. It could be Airflow, it could be Data Factory, it could be AWS Glue, or there are plenty of platforms that perform the ETL part. The suggestion would be is it should support reading kind of external definitions and processing them. The part of the addressable. So all of the data that's loaded, because you have the definition, you can create a uniform way to get the data from. It could be multiple storages, but the access could be one. It doesn't matter whether you create your own schema of data, whether you use the OData, some standard. One of the things that works pretty well is GraphQL, because it's not the perfect solution probably for this addressability, but it has the introspection endpoint out of the box. It has a lot of documentation how to use it. It has a lot of tooling. So if you're supporting like GraphQL queries, you can from the definition you can create the GraphQL definitions, and you immediately have this consistently addressable way of getting that data. This becomes auto-generated from your definition, and you get the endpoints. So you get the API immediately. That could be leveraged by applications to show the data. And like Tableau and Power BI, most of them does support capability of querying the RESTful services and getting the data out. Maybe more problematic on the Tableau, but basically you can have one API and get those. Sometimes people actually build a SQL ODBC driver on top of the GraphQL, and then you can actually just query it as a database. One consistent way of retrieving the data, if you discover that in the data catalog, there is a concrete way of getting the data out. Self-describing and interoperable. I've mentioned it a little bit, but the data description should be stored as a code. So it's self-described. And why do we want this? Because that will allow your teams also to collaborate. So basically, if you want to create a new data model, you just do the pull request. Define the data, do the pull request, maybe the platform team or some other team just kind of reviews whether all of the bits and pieces are in there, and you pull it in, automatically pipeline starts pulling the data, and you immediately get it on the other end. And it should be self-describing, so it should be contained in one place. You should not be throwing stuff around the date. So you cannot put, let's say, descriptions in Confluence or somewhere, and then the definition, maybe the code part, in the Git, and assume that it will work some way synchronized. Already mentioned that all of the models and sources should be versioned, so you know what happened, you know how did it grow, how did it change, who changed it. So if you're using the version control like Git, that you get out of the box. And the good part is that it also provides like a living documentation. So anything that's defined, you will see it in the code. The engineers would be able to go in and figure out what's going on with the data. And I've mentioned sometimes you can do the generated data. As I mentioned, some of the tooling provides, like, if you create a data source, it just pulls everything what's available there and automatically creates you those stubs. So it will pull the table name, it will pull the columns, maybe column types, but the problem is that nobody will have the descriptions or anything in there. So it becomes like, if you describe it, you're going to have a full catalog. If you don't, that's missed. And that is sometimes meaningless because it pulls everything. So you will get various tables that might not be even needed. The interoperable part, again, I also mentioned that one thing means the same across all of the data sets. So whenever you discover things and you want, if analyst kind of discovers some data sets that he wants to join and create a model out of the two data sources, it should be unique across the data set. If it's order ID and I call that an order identifier, it's going to be order identifier, same order identifier from the domain perspective in the other data sources as well. And one of the things when you have the data catalog or all of your definitions in one place, this automatically reduces the duplication of the data. So you can actually go in, figure out if the data is already in the platform. You don't need to load it again. You can do the models out of it. If it's new stuff, then you go and explore. The other part is doing the transform part after the load. This also helps because you load the raw data, you do the transformation, and the transformation is done as a model. That means you know the business logic is in the documentation, it's in the model. So it's not something happening in the pipeline itself, but basically you know, I took these data, I transformed the data in that way. It's documented. And lineage, as I mentioned before, if you have the lineage, it also reduces the duplications and it becomes easier to find what you need. The security part. The security part, by this time you probably already see how it becomes more easy to kind of define the data, let's say, protection or some security related things. And it could be that I have a tags. I can put the tags on specific data, whether it's PII, whether it's public, non-public. So basically you can immediately say, I will not expose anything that's not marked public or that's not marked for the publishing. And you can do that for your organization. You can build it into the configuration immediately. You will be able to backtrack to see what data, and if we combine this with addressability, with the one interface that we're getting, that means I can perform all of the checks before the data actually leaves your service. And I said, all of those rules can be applied uniformly. So because, like, if we choose the GraphQL implementation, we can simply drop the items that the people doesn't have access to. You can create your access control list at this level as well. The good part as well is you have that in documentation. So it's in the self-describing thing. You can immediately see what the data is sensitive, what is not. And additionally, you can even store the expiration of the data. Like GDPR, if you're storing it for 2 years, you can clearly mark that at a certain point, this field is expired. And you can build into the platform, into the load, kind of the clearing part as well. So going back to the last important bit, is the ownership. So we talked about the distribution domain, and if we shift the whole culture from just having the data in one bucket, basically going into let's define the data that we have and operate that data in a concise manner, the ownership is very important, because as I said in the beginning, it's not going to be one team that owns everything. You want the self-service, and you want all of the teams to be able to contribute, add additional data into one place. So this is just a reference diagram how that could look like. If you're running the data warehouse as a Snowflake, you have GraphQL services that actually feeds the data for the consumers. You have Airflow for doing the ETL parts. And you have the, let's say, model creators or data owners the difference between the data owner and model kind of creator, the owner is actually who takes it from operational database and defines what it is for it to be moved into warehouse. The model creators are basically either joining or creating the aggregations or doing appropriate granularity on the data. So that would look very simply, right? If I want to create a product, this data is a product, I would start probably from this place. So what is the requirement? If I have the data, that's kind of clear. I just use the data. So that's the reusability of the data. And you have only one ETL. That is, you have only one pipeline that loads the data. And it could be used in multiple consumers. So whether it's Tableau, whether it's Power BI, whether it's the front end of the application. If it's not here, I try to figure, do I need to create a model? Or do I need to add that data? Is it available in some form? If I just need the aggregated view of the data that's already in the system, I create the model. So basically, this would be data analyst that goes in, creates a model, pushes it into the platform. The platform picks up the changes. That's deployed as a static thing. The orchestration takes and creates the model, either directly from it as a view. dbt supports the creation of views automatically, and it becomes available immediately because it's in the data catalog. It's already on the endpoints. You can use it. And you have all of the necessary data that goes with it. If it's not there, you go and ask for the team, where is the data? Which product? Internally, in which transactional database it lies. The owners, because they know about their own data, they create a definition. The owner is creating the definition, so they know what each column means. They know the data. They know what they can expose. They know what should not be exposed. They create the definition. It's, again, picked up automatically. The workflow starts loading the data. And you kind of follow the same. Do you need to create a model? Yes, you create the model. And the good part is that you do it only once. So if you created it, the important part is that the analyst created it, they can extend it. So the model extends with the multiple dimensions, and everyone can use it. So you don't populate, let's say, different dimension models in one place. You just kind of extend it. You just add additional field that you want to aggregate. And you get this kind of self-service thing that automatically becomes in documentation. You see that, and you have a proper way of using the data. That is, you have the whole flow. You know what's going on there. So to summarize, is not changing the way how you deal with the data. It's just going to be like with the data lake, right? You will be just putting more and more. You will have just a bigger waste bin. But you will have exactly the same problems. Nobody will understand. They'll create the duplications. And nothing good goes from here. And the data as a product is a cultural change. Kind of moving into this data platform world, or definition first way, is a cultural shift. It's not that easy to change, but you cannot buy it. You can buy the tooling around it, you can switch the tooling around it, but the concept to save is difficult. And data platform is just a piece of the puzzle. So it plays a role as a distribution domain. It's an important bit, but understand that it's not the whole picture. That's it from me. And any questions?